Hello, my name is Jean-François Fortin, and I'd like to introduce you to the Olympus NDT RTIS. RTIS stands for Rotating Tube Inspection System. These systems are designed for seamless and welded pipe inspection using phase array technology. The RTIS can be set up according to the required inspection configuration. This includes the inspection of longitudinal, oblique, transversal, and lamination defects, as well as wall thickness measurements. Possible configurations for the RTIS include 1 or 2 inspection heads for increased productivity. In a 2-head configuration, 2 calibration stands can be included. This allows the calibration of one head while the second is still inspecting, thus ensuring continuous operation. The inspection technology used in the RTIS is based on phase array probes integrated in a water wedge assembly. A proprietary end-of-tube inspection algorithm is used for the detection of transverse defects up to 5 mm from the pipe edge. Eddy current array technology can also be integrated into the system, allowing a double technique inspection in a single pass. Due to the flexibility of the phase array technology, configuration and inspection modes are typically changed only by software, with minimal intervention on the inspection head. Throughout this video, I will present the RTIS and its main components. Right now, we will send the carriage to its maintenance position so we can perform a changeover for a new size of pipe. So we can send the carriage automatically to its maintenance position using the carriage assignment on the HMI. So if I assign the carriage to the maintenance position, and then I initialize the system, the carriage goes automatically to the maintenance position, and then I can lower the inspection head automatically also. So this is the inspection head of the RTIS. At the top of the inspection head, we find the heart of the system, the quick scan LT acquisition unit. It does not need any active cooling to function properly, so it can be used into any industrial environment as is. The electronic used on this system is of the 32-256 models. It allows the firing of 2 apertures in parallel with the use of a link cable. 2 quick scans can fire on the same probe, thus allowing us to fire 4 apertures in parallel. Below the quick scan LT acquisition unit, we have the 6 water wedges, which houses the phase array probe, but also the conventional UT probe used for coupling check. The number of water wedges can be different according to the required inspection configuration. In this case, we have a 4 water wedge configuration along with 2 pre-wet at both ends of the inspection head. The first water wedge in this configuration is a pre-wet. It is used for wetting and cleaning the pipe. The second water wedge is used for transverse inspection in the forward direction. The third water wedge is used also for transverse inspection, but in the backward direction. The fourth water wedge is used for longitudinal inspection in the clockwise and counterclockwise direction. The fifth water wedge is used for wall thickness and lamination inspection. And the last water wedge is a second pre-wet that is used when we do inspection in the reverse direction. The RTIS inspection head is designed for modular integration and easy maintenance. All components can be easily accessed for regular inspection and maintenance operation. The phase array probes are very easy to connect to the quick scan LT acquisition units. So I will now describe in details the different components of the water wedge. First, at the top of the water wedge, we have an air cylinder which controls the down and up movement of the water wedge. We have the main part of the wedge. This part of the wedge is fixed on a yoke that allows it several degrees of freedom so it can follow the pipe during inspection. At the bottom of the water wedge, we have the wear plate, which is in direct contact with the pipe. So the wear plates protects the rest of the wedge and prevents it from wearing out from friction. On the top of the water wedge, we can find the phase array probe that is used to generate the UT beams. On the right of the water wedge, we have the conventional UT coupling probe that is used for coupling check. In black, we have the probe holder, which contains the water column required for inspection. And then at the front of the water wedge, we have the water inlet hose, which bring the water that is necessary for coupling between the wedge and the pipe itself. The changeover process on the RTIS, that is changing the configuration of the system to go from one pipe diameter to another, sometimes require the modification of the water wedge configuration. This can be done quite easily by changing the probe holder and the wear plate. The first thing to do in the changeover process is to change the wear plate from the pipe that we were inspecting to the new pipe size we want to inspect. Now that we have changed the wear plates, the next step in the changeover process is to change the probe holder or the water column. In order to do this, we need to remove the water wedge from the inspection head. The first step in doing so is to remove the water inlet hose and the coupling probe extension. We can then disconnect the phase array probe from the QuickScan LT acquisition unit. Once this is done, the water wedge can be easily slipped out of the yoke and removed from the inspection head. Now that we have taken out the water wedge from the inspection head, we need to change the probe holder, thus the water column. But first, we need to remove the phase array probe from the probe holder. This can be done with a very simple hollow shaft screwdriver. Now, before we can remove the probe holder from the wedge, we need to remove the water from inside. Now that the water has been removed from the probe holder, we can finally remove the probe holder from the wedge. This can be done with a single Allen key. So now that we have removed the current probe holder, we can then change it for the new one, corresponding to the desired water column for inspection. Now that the probe holder is fixed on the water wedge, we can fill it out with water. and we can reinstall the phase array probe. The probe holder is equipped with two valves that allows the water to escape the probe holder when we insert the phase array probe, thus making sure that we have no air bubble inside of the probe holder. The water wedge is now ready to be put back on the inspection head. Putting back the water wedge on the inspection head is as easy as it was to take it out. We just need to push it inside the yoke and lock it in place. Now we have to reconnect the phase array probe on the QuickScan LT acquisition unit. Secure the probe cable. And finally, reconnect the water hose and the coupling probe. Now the changeover has been completed for this wedge and it is now ready to use. We need to do the same thing for all the water wedge used in this particular inspection configuration. The calibration process for the RTIS is very simple and fully automatic. It can be launched and controlled from the HMI and from the QuickView acquisition PC. So the first step in the calibration sequence is to validate the length of the pipe, which is why the carriage is going to the left end of the pipe. Once the length has been confirmed, the carriage will move to the position of the first defect to be calibrated. In this case, the first defect is a transverse ID notch. The first probe to be calibrated will be the transverse forward probe. In QuickView, we can see the amplitude response of every single apertures on the transverse forward probe as it is going over the reference defect. The goal of the calibration is to equalize the response of every aperture to a target of 80% plus or minus 5%. The precision can be adjusted by the operator. As you can see, after the first pass, none of the apertures were at the 80% response level. So we must calibrate all of them by adding or removing to the gain level for each aperture. Now, as you can see, after the second pass, the calibration is perfect. We can now move on to the second defect, which is a transverse OD notch. just like for the transverse ID notch, the goal here is to equalize the amplitude response to 80% plus or minus 5%. The operator has the choice to manually select which aperture needs to be calibrated, or the operator can select all the aperture at the same time and confirm its choice to the Quick-View acquisition software. Once the operator clicks OK, calibration gains are added or subtracted to the corresponding detection gate. After the second pass, calibration is perfect. We will now move on to the longitudinal OD defect. The process for the calibration is always the same. The system will do a first pass and record the amplitude response of every aperture as it goes over the defect, and then the operator can select the aperture that needs to be calibrated in order to reach the 80% target. The system will then do a second pass to validate that the calibration that was applied after the first one is correct. So the calibration is now finished for the longitudinal defect. The check calibration sequence is used to validate the calibration. It is very similar to an inspection sequence. So during the check calibration sequence, the carriage will go at full inspection speed over the calibration pipe, and Quick-View will record the amplitude response from the reference defect. For the check calibration to be successful, we have to detect all of the defects over the alarm level. In this case, the alarm level is 50%. as we can see, this check calibration was successful as all the defects were detected above the alarm level of 50%. So now that the system has been calibrated and that we have validated the calibration with the check calibration sequence, we can inspect the pipe with the 2 inspection heads. So as we can see, each inspection head has its own preview acquisition PC for data analysis. The information recorded by each inspection head is then sent to a supervisor PC where it is merged and displayed in the inspection strip chart.